Good day to you out there. I want us to look at a topic in mathematics called algebraic fraction. Algebraic fraction in mathematics, from the name itself, an algebraic is a form of expression which have a variable within itself. For instance, if you have 3x plus 5 or 3x, this is a very good example of an algebraic. Now, a fraction, this is algebraic. A fraction is a form of expression in mathematics that has the numerator and denominator in terms of x. Now, when you see an algebraic of this nature, and we have what they call a fraction as well, the two words come together, making it algebraic fraction. That is a kind of algebraic expression in a fraction form. That is the meaning of that. Now, for us to have a good algebraic expression or algebraic fraction, it means that the denominator of such a fraction must be an algebraic expression. If not, such an expression cannot be regarded to as an algebraic fraction. For example, if I have 3x plus 5 over 3x, this is a very good example of an algebraic fraction. But if I have 2x over 5, this is not an example of an algebraic fraction, because the denominator here is not algebraic. It's not algebraic. Therefore, we cannot regard this particular information here as algebraic fraction. Now, let's look at the type of algebraic fraction we have. We have one we call the monomial fraction. The monomial fraction is a form of algebraic fraction that has only one term at the denominator. For instance, we can have a value like 3x over 7x. We can have 2x plus 3 all over 3x. Since all these values at the denominator are just a single term, 1, 1, that kind of fraction can be regarded as a monomial algebraic fraction. Now, if we now have a kind of expression at the denominator whereby the value there is more than 1, it is an algebraic expression that is more than 1 terms, then we call such a kind of fraction an binomial fraction. Binomial fraction. We have example of it. You have 3x over 2x plus 3. You can have 5x minus 3 over 7x minus 1. You can have something like 2x over 2 plus x, 1 minus x. All these are the example that we just stated here. A very good example of binomial fraction. Now, we are going to look at some questions as regard algebraic expression, and we will solve it together. Please stay tuned as we solve those questions together now. The question here says, simplify 8 over 76 minus 9 over 6x, 8 over 7x minus 9 over 6x plus 3 over 4x. Now, I will advise you, whenever you want to work on this kind of expression like this, whereby you have those signs, separating them, just bring the positive together, separate the signs. Alright, so this is a positive sign, this one is having a positive sign, this one is also having a positive sign. Bring them together. You are going to our solution now. 8 over 7x plus 3 over 4x minus 9 over 6x. Now, each of them are fractions, so we need to find the LCM of the three of them. The LCM of 7, 4, and 6 is 84x. 84x. Now, 7x in 84 will be equal to 12. Why is it 12? Is it we cannot have the x there any longer. 12, that is 7x over 84x. So when you call the x is out of it. 7 in 84, that will be 12. 12 times 8 will give us 96. Plus 4x in 84. 4 in 8 is 2. 4 in 4 is 1. That's 21. 21 times 3 will give us 63. No x again. Minus 9 in 6x in 84x. That will give us 14. 14 times 9 will give us 126. Now, adding 96 plus 63 minus 126 will give us 33 over 84x. This is the final answer to this question. Take note of it. We're going to have another question now, where we're going to have a binomial fraction. This other question says you should simplify 3 over y squared plus y minus 2 over y squared plus 3y plus 2. If you look at this question very well, you will discover that this is a very good example of a binomial fraction, because at the denominator, the terms we have there is more than 1, unlike the first question that we solved. Now, how do we solve this? They are fractions. So what you do here is to find the LCM. But before we go ahead to find the LCM, let's first of all simplify this, the denominator values we have here. For us to simplify it, we are going to have 3 solution now, 3 over y into bracket y plus 1. What I do here is that I try to factorize this part. Now I simplify it. I said y is the common term between here and here. Y squared divided by y is y. Y divided by y is 1. Minus 2 over, when we factorize this value here, the value we are going to have at the end of the day will be y plus 1, y plus 2. If you try to expand this value here, we are going to get back this expression. Take note of it. If you try to expand this one, you get back this expression. Or should I do? Let me quickly do it for you. Y plus 1, y plus 2. Or let me just factorize this. Factorizing this one, we are going to have 2 times y is 2y squared. Don't forget, in factorization, I will look for two values that when I multiply the two values, I will get 2y squared. And when I add the two values together, I will get plus 3y, which is a y value here. Now, the two value will be 2 times 1. For us to have 2, we cannot say 1 plus 1. 1 times 1 cannot be 2. So it's only 2 times 1 we can have to have 2. So it's going to be plus 2 multiplied by plus 1. So we're having 2y multiplied by y will be equal to 2y squared. Then 2y plus y will be equal to what? 3y. So this equation now, this information here, I'll satisfy this equation. So I can insert this value here now. I'm having y squared plus 2y plus y plus 2 equal to 0. So we are going to have, what is the common value here? We separate it, y to bracket what? Y squared over y, 2y over y plus 2. What is the common value here is 1. Then we have y plus 2 as well. So we are going to have, what is the value that are not inside the bracket? Y plus 1. One of the one in the bracket, y plus 2. So we put it like that. Y plus 1, y plus 2. Then you go ahead and solve the equation. Now, this equation has been like this. Definitely we have to find the LCM. What is going to be the LCM of all this information here? It will be y, this particular y plus 1 in bracket, and y plus 2. Those are the terms that will multiply one another. Y plus 2. Now, you now say y plus 1 in all this. You know that when we place them on over one another, we are going to discover that it's only this y plus 2 that will remain. So it will be 3 into bracket y plus 2 minus y plus 1, y plus 2 in all this. You place it on one another, all these 2 will be cancelled out. It's only this y that will remain. Y times 2y, that's 2, that will be 2y. So we're having the value at the numerator to be equal to 3y plus 6 minus 2y all over y plus 1 y plus 2. Put it in bracket like this. Put it in bracket like that. Then from that now, we now look at the value and we collect the like terms now. Solve the numerator, we are going to have 3y minus 2y. We have collected the like terms now, plus 6 over y plus 1, y plus 2. So we are going to have 3y minus 2y, that will be what? That will be equal to y plus 6. That is what we have at the numerator now. Then you have y. Then you have into bracket the expression. Let's return it back to the form that it is there. Y squared plus 3y plus 2. That is the answer we are going to have for this expression here. Let's look at one more question as regards this particular part of the algebraic fraction. Another question here. This question says simplify y over y minus 1 over y. This particular expression is just telling us that we should just follow the information given to us there. For simplification, you just say solution y divided by, that's the meaning of that over, divided by y minus 1 over y. This makes this particular set of terms to be in different parts now. This y is the same thing as over 1. So we are having fraction here. So we find the LCM here because they are separated by negative value. You cannot find the fraction with this division sign. No. When there is division, we don't find the LCM. No. Now, what is the LCM of 1 and y? That is y. 1 in y is y. Y times y is y squared. Minus y in y is 1. 1 times 1 is 1. So we are having y divided by y squared minus 1 over y. That becomes y multiplied by, then this denominator here, immediately this one change to multiplication, this division change to multiplication, this denominator will come to the numerator, y over, and the numerator comes to the position of the denominator, y squared minus 1. So we are going to have y squared over y squared minus 1. Y squared over y squared minus 1. That is the answer to this particular question. On that note, we have come to the end of this particular algebraic expression. More of this type of question or solution to most of the questions are available on our YouTube channel. Please do subscribe to this channel so that you'll be able to have more information from our channel. Thank you.